We are now entering an exciting phase of AI with the rise of advanced reasoning models like Claude 3.7 Sonnet, DeepSeek R1, Grok 3, and OpenAI's O1 or O3 Mini. These models aren't just good at holding conversations. They can write research papers, invent new theorems, and even come up with original proofs. This brings an important question. What exactly are these reasoning models and how are they trained differently in comparison to chat models like GPT-4o or GPT-4o Mini? If you haven't checked out my previous video on how chat models are trained, do check that out because that sets the context for this video. But coming back to reasoning models, on the surface, both reasoning models and chat models might look the same. You ask them something and they respond. But the way they think and work underneath is very different. Just bear with me for a few minutes and you'll see how. Chat models are built for conversation. Say you ask it something and the answer the model has given isn't quite right. What do? You can correct them, you can follow up with questions, you can guide them towards what you really want. Basically, the model learns what you want as the conversation goes on. That's why we say chat models follow a guided approach because you, the user, are steering the conversation towards the answer you want. In contrast, reasoning models are built to dive deeper from the very beginning. Instead of relying on back and forth to reach clarity, they aim to get it right in one shot. You provide all the necessary context upfront and the model processes it internally to deliver a well-reasoned, complete answer. Unlike chat models, they don't depend on user corrections. They are built to think through the problem, not just talk through it. Now that we know how reasoning models are different from chat models, let's understand how they are trained. The major difference in the training process of these reasoning models is in the attempt to minimize or even eliminate the reliance of SFT and just rely on reinforcement learning. Why? Well, if you recall, SFT involves training the model on a curated data set of questions and high quality human written answers, right? This helps the model learn how to respond in a way that seems useful and coherent. But if you actually think about it, this process is like spoon feeding the model. The reason why I say this is because the model is being shown exactly what to say and how to say during the SFT phase, which means that we are not really leaving room for the model to explore different ways of thinking or reasoning. Consider a child, for an example, who has just learned division at school. Now, whenever they face a division problem, they most likely try to solve it only in the way their teacher showed them. But does that mean there aren't other ways to solve the same problem? Of course not. However, because the child has been conditioned to follow a fixed method, they don't feel the need or even the freedom to come up with their own method. The same logic applies to large language models. When they undergo the SFT phase, they start to mirror the thought process of the human annotator who created the training examples. And while that helps ensure the model gives safe or standard answers, it also limits the model's ability to think independently or discover new approaches. This is exactly why reasoning models aim to skip or minimize this SFT and lean more towards the reinforcement learning. Reinforcement learning doesn't just feed the model with ready-made answers. It rewards the model if it figures out things on its own based on how well its reasoning aligns with what humans prefer. Over time, this allows the model to develop its own internal reasoning process instead of relying on memorized templates from SFT. So, in a way, reinforcement learning helps the model grow beyond the training wheels of SFT, enabling it to actually think rather than to just repeat. So, did the reasoning models like DeepSeek rely entirely on reinforcement learning? Well, the answer is bit of both. Yes and no. Yes, because one of the DeepSeek's earlier version, known as DeepSeek R10, was trained entirely using reinforcement learning based algorithm. What sets this version apart was its unique behavior during training. Instead of just trying to answer, the model apparently began revisiting its own thought process, exploring multiple approaches to solve a problem before settling on a solution. And as the pattern continued, researchers noticed something interesting. They noticed that the length of the model's responses gradually increased. Why does this matter? Because this showed that R10 was spending more time reasoning internally with itself before answering. It means that it was thinking deeper rather than rushing to reply. Thanks to reinforcement learning, R10 did really well on reasoning tests, even better than models like Claude or GPT-4o in some cases. But here's the problem. Even though it was smart, researchers found that its answers were hard to understand. Why? You might have guessed. Because there was no SFT. SFT was the training step where the model usually learns how to respond clearly. Since DeepSeek R10 skipped that, it could think well, but it couldn't explain things properly. So the team decided to bring back SFT, but in a small and smart way. That gave us DeepSeek R1. Now you might ask, wait, if they added SFT back, isn't it just like any other chat model now? Not really. The key difference is DeepSeek uses SFT just a little only to help the model express its thoughts better. Most of the training still focuses on reinforcement learning. So it doesn't lose its ability to think for itself, but at the same time, it also learns how to say it in a way that we can understand. That's what makes DeepSeek's R1 special. It's like a super smart person who finally learned how to explain things clearly instead of mumbling some genius level thoughts.